Hello, people of the internet. The Christmas break is over and we are right back at the office, aka my living room. Hopefully, you are ready for the new year and let's start working on something. So, for today, we have this ticket that is saying that some of our copper AWS builders sometimes, which is always fun, fail to boot because of swap. I know nothing about this issue. The reason why I took it is that I want to upgrade our builders from Fedora 42 to Fedora 43, but my teammate said, hey, before doing that, we should fix this issue because this needs to be fixed when building a new builder images, not when starting them. So we need to do that before upgrading the new builders to 43 and building the image for that. So I know that the only thing I know basically is that I cannot go to our Ansible playbooks that basically are being run on already started VMs in AWS because that's too late. We need to go to the code base that handles creating the initial image that is being spawned in AWS, and we need to fix it there. So that's one thing. The other thing I know, because Pavel told me, is that this is some kind of race issue. So those are always fun, and the word sometimes points to that. So there is some race issue. I have no idea what the race issue is. Maybe the disks are there are two partitions, as you can see, or maybe two disks, and maybe they are basically attached in a random order, and therefore sometimes they are in the wrong order than we expect, and that's the problem. I have no idea. So, and I'm not sure we will be able to figure that out actually. So let's take a look on it, give it an hour, and if we cannot figure the solution, or maybe at least where the problem lies exactly, then we will ask Pavel because he knows where the race issue is, but I don't want to bother him because he has a lot of other work to do. So let's give it an hour, and if we cannot figure it out, then we will ask and we will continue on it later. So yeah, let's do that. Okay, we immediately see this is some sort of Ansible task. But so my first instinct would be, hey, go to the Ansible playbook. But yeah, they told me this is not, the issue is earlier. So my next thinking would be, this script is probably baked into the image, and it is only being executed after the image is running. So the bug is probably inside of this script. So, and that script is baked into that image. So we should probably find the repository where this script is. Okay. I think we have some project for this here, and I think I'm the one who created it. So I think the Copper Image Builder is the right project. We should probably protect the branch, but not now. Yeah, I think this is the correct one. I see Docker file, container files, make some README. I think this is the correct one. Do we have pull requests here? Yep, we have. Yeah. This is definitely the correct repo. So it is called Copper Image Builder. We will go to our repo. I mean our clone of that repo. So Copper Image Builder. We are on the main branch. Let's pull changes. Cool. Now, I bet that if we go to it in Emacs, image builder, which is this one, and if I search for the copper partitions, yep, it is here. So we have copper partition service and we have copper partitions sh. So let's take a look at the service first, because I bet you it just starts the script. So repartition something, and it is after networking, sure, and basically it just executes the copper partitions script. So no magic here. Let's take a look at the script. Copper partition, and this one will be fun, believe me. So let's take a look. Oh yes. So you may already know me a little and know that when I see bash, I kind of okay. So this will be hard for us. Also, we are seeing this fun echo into fdisk. So yeah, this will I'm bad at this kind of code, so yeah, this will be definitely not fun for us. Okay, how do we read this? So sure, we show errors. It depends whether, okay, I don't know what this is yet. We have some results directory. Yeah, this is a common thing, and we want it to be 16 gigabytes. Okay. Now we have some function to repartition device path into results plus swap. So yeah, this takes a path to the device. So I guessed that would be something like this. Oh yes, yeah. This is the device, and then there is the prefix. So basically this is the letter here, the prefix letter. Okay, so we have the function here. We know we have it. Let's skip it for a bit. Now we have try indefinitely. Okay. It just I don't know if you can read this, but saying it is try indefinitely, I suppose it just tries something, probably its argument, until it succeeds. Okay. Mount points as files. By the way, we are at 13%. This is long. Okay. Mount points as files. So prepare large files if we don't have device to work with. I have no clue what this is. Make sure TMP is TMPFS. Okay, so we are just unmasking and starting a service. I don't see a problem here. Generic mount. Find a very large volume that one will be used IBM Cloud assigns the swap volume name randomly. Hypervisors have, yeah, okay, so this shouldn't be too much relevant to AWS, since, or maybe it is actually, because hypervisors, okay, have some static value here. It says IBM is random, and it doesn't mention AWS. So actually, this could be that problem. This could be that problem because this, yeah, this code basically goes through all the volumes and figures out if the volume is basically larger than this. I don't know what this number is. I guess 16 gigabytes or 15 gigabytes. Then it breaks. So it finds the name, but it also repartitions it. Oh, yeah. Okay. Anyway, it finds the largest volume that is supposed to be the swap or the disk itself. Oh no, no, it repartitions it. So we have seen this. It calls this function. Okay. So it finds the largest volume and does this function on it. Makes sense. So I don't think the problem will be here actually, but maybe. And now we have some tests that are, I mean, not tests, conditions that are like for specific clouds, I guess. So only files on our hypervisors have this. This is only OpenStack, sure. Only Power 9, which is in OpenStack. So okay, this is irrelevant for us. AWS. So maybe, definitely maybe, because this is the AWS specific thing. Else generic mount, okay. Now we are formatting something and creating stuff and so on. So this is generic code. I don't think this is the problem for us. So let me take a look inside of this. Do we know if this is x86-64 or if this is ARCH-64? So we are seeing fdisk on dev NVMe 1. So I think we are talking about x86-64 in the bug report. But I guess this makes sense, maybe. I guess. So this, to me, it seems the problem is somewhere in the repartition device. So we will now finally slowly walk through this function. By the way, you know that I don't like to work like this, because I usually try to or strive for a short iteration loop and putting a debugger into the code and just investigating the problem live instead of reading the code, which I find much better, because you can incorrectly read the code and understand it incorrectly. But if I print some variable in the debugger and it has some value and it is a different value than I expect, definitely there is something wrong. So I like to do it that way. But this is the kind of situation where we cannot do that. The problem is it takes I don't know, I don't remember actually, but maybe half an hour to build the images. And the produced image is around 10 gigabytes or something, and they are for multiple architectures. So we need to upload them into the correct storages, into the correct clouds. So that's 10 gigabytes. It takes some time, and then you need to somehow run it on the like on Copper backend, so that we can use it, right? So that's at least 2 hours of doing stuff to see the result, right? So this sucks really bad. So we cannot do it that way. Of course, this is a specific issue, because in this project, if I take a look into Copper Image Builder and go to container file, for example, like we try to do a lot of stuff into that container file. So the iteration loop for that would be very short, because I can run that on my machine. Just I know, I guess we have makefile for that, so it would be, oh god, what is this? Yeah, there is some, I don't remember where the command is. I probably in this documentation. Yeah, this is the one. So if the problem was actually inside of that container file, I could just do this and that's it, right? I would have reproduced it immediately. But the problem isn't here, the problem is inside of the script. So yeah, this is really hard to debug actually. We could maybe run an image or run a VM inside of AWS and try to manually change the script there, and then we could figure out what's wrong and only fix it inside of the script afterwards. So we will probably do that. Yeah, we will probably do that. But let's start with reading the reading the code here. Okay, nothing that needs to be attended to. Okay. So we have some device and some suffix that we got from the new, from the caller, right? So in case of AWS x86-64, we get these two values. Now, we are piping this into fdisk device. So we are doing fdisk on /dev/nvmn1. I probably said that incorrectly. Anyway, this one. And piping this into it. So we are doing new. New is create. New partition, primary partition of 16 gigabytes, because we have that here. Then we do new primary partition. For some reason we are specifying number 2 here. Okay. And we are writing to that device. Cool. Then we do part probe actually. So this is discovering new disks. But maybe what exactly part probe does, so that we don't assume incorrectly. So part probe inform the OS of partition table changes. So we are basically discovering new disks. I'm not exactly sure why it is part probe or nothing. This is nothing, right? This is basically 3 dots in Python, or pass in Python, or to do in Gleam or something like that. Okay. Now, partition is device. Oh, the race issue must be here. Well, must it be, actually? The device is, we know what the device is actually. The device is this one, right? Then there is the suffix and the second partition on that device. And what do we do with that? We are waiting until it exists. Sure. And then we decide. Then we decide that the results storage. Then we decide that the result storage is the first one, and the swap storage is the second one, which would be a smart assumption, right? Because we are creating this one. We are creating this one first, and we are explicitly even saying that the second one is the swap, right? 2 is 2 the number of the partition, or the type. So this would be the default, the file system or something like that. So this would be the default one. This would be 2, which would be maybe swap. Let's try to run the, it's probably not relevant, but if we run fdisk, right? So if I do fdisk L sudo, so if I run fdisk on, I guess this, not L, sudo fdisk this, so this could destroy my disk, right? So this is a probably bad idea, but we are not going to write on that, so we should be fine. And we are doing new partition number. How is it that we are doing P here? Next. That's weird, right? But I remember how it used to be. What if we do it in a container, for example? cd, let me go here. So if we run, for example, docker run it Fedora, right? Sure. Do we have some? We don't have a disk. Sudo dnf install. I have never tried this because, yeah, I have never tried this. So maybe it will be a nonsense. Yeah, we don't see any disks in this. Okay. So what if we boot? How is libvirt? No, virt manager, right? Virt manager. What if we boot this one? So this is the Copper Builder image that I tried to build the last time. It is on my machine, right? The problem is there some login? It should be, I think, in the Docker file, container file, there is some login for debugging. Maybe it is passwords. Okay, so maybe we set root. Hopefully we did it. So root. Yeah. Okay, we are in fdisk L. Okay, we have some partitions. So if we do fdisk on def VDA and do new one, partition number. How the hell? Like if we do P as they said, it's incorrect. No free. Ah, shit, we cannot. That's annoying actually. I know that M for help. I know that we have like this is really weird. Like I know this is a primary or extended, but how is it it's in this order when fdisk create new partition? Let me see if they show something somewhere. Fdisk this new. Oh yeah, exactly. Primary or extended. Sure. How the hell it is not asking me that. So we do primary in that. Yeah, and there is the partition number 1 is default, and they do 2. So we could, yeah, okay. So this is the example, like according to this example, this is correct. And I think it is correct even now. It's just I'm trying fdisk locally on a mounted disk, which is finished and so on. So probably it's a different situation. So I don't think the problem is here. I actually think the problem is here in the discovery. And for some reason, I think they are swapped here. Can we confirm that by the fdisk output here in the ticket? So we are doing these, which is as expected, and then we pipe it to fdisk. So we are seeing what do we see inside of that fdisk? So sure, this is the standard output that we have seen in our fdisk. Now, oh, check this out. Check this out. So they are seeing this. We are seeing the same problem here that I actually reproduced on my machine, right? I already closed the VM, but we have seen that. And that's okay. So the thing probably is, this is probably not the right device. That must be it. Because if it never worked, because for example the fdisk syntax or something like that changed, then N and then P would never work. Never. It doesn't work only in some situation, on my machine for example. So I think we are just passing it sometimes the incorrect disk. So this must be the incorrect device, I think. Let's jump to AWS and see what kind of disks the builders have. So to get into the Fedora AWS, we have some special login link. I need to provide my Fedora password here and my second auth token. So if we log in, we can see the Fedora AWS account here. Now the builders run in EC2. And we are interested in instances. So this is a lot of stuff and not only copper related, it's all in one place. So we need to be careful here, basically. And we can filter our builders with copper instance equals, let's do devel, just to be sure we don't mess anything up, and copper purpose equals builder. What? This is weird, right? It's weird. it's most certainly weird. Maybe it is not, because maybe we are conservatively running the resources on staging and don't have any instance running to not waste money, possibly. So if we go to SSH and we go to the Copper backend devel, yep, this is the right instance. So as a Resalog user, we can control the Resalog, and we can go Resalog maintenance resource list, and we can see we have one builder on a hypervisor, one starting builder on a hypervisor as well. This is ARM, not x86-64. However, this should appear in the AWS console, right? Those two, yeah, this is also Oregon State University open source lab. So this is PPC builder, PowerPC builder, and those two as well. So this one, however, confuses me. How is it not appearing here? North Virginia is correct. What do we see for its logs, by the way? We don't see anything for its logs. So, so that could, yeah, there is nothing actually. So that could be possibly what's wrong. So if we do Resalog main resource info, is it? Starting, there is some timestamp. Weird. You know what we will do? We will edit our Resalog server main pools YAML. This is the one, and there should be so no, this is powerful builder. We don't want the powerful builders pre-allocated. We are actually interested in x86-64 spot dev. Yep, exactly this. And for some reason there is 0 allowed. I want to temporarily allow them because I want to test this. So we are going to I don't think we need to restart Resalog, but we will do that anyway, just to be sure. But I think the pools YAML are hot reloaded actually. And if we do Resalog list, and we immediately see x86-64 spot dev starting, and we should have a log for that. Yep, it's allocating. Okay, let's wait until it actually allocates and then connect to it in the AWS. So while this is booting, I will go pee and go back here. So give me and this a minute, please. Wow, this was very fast. This tells us that the instance or the VM started, and this is its IP address. So we can definitely, or we should definitely be able to find it here. By the way, we can add the filter as I wanted to. So that was copper purpose. I cannot type. Copper purpose equals builder. And now we see even the ARM one. So there was definitely some problem with the staging instance before. And the builder somehow got lost. Anyway, we have this one because we are interested in the x86-64 one. So we can open it here. Yeah, we could open its terminal here, but we can do that also from here, right? We can do SSH root at this. Yeah, that was a better idea. I don't know why we didn't do that in the first place, but whatever. Whatever. Now, if we do, oh yeah, I remember why we didn't want to do that. So if we do fdisk L, yeah, we can see two devices, P1 and P2. Two partitions on one device actually is more accurate, and the partitions are P1 and P2. Now, this is the 16 gigabytes one. And this is, what is this? We should take a look here. That's why we opened it. So we have storage. We have storage and we have two things attached. Two things attached, yeah. Okay. Anyway, so how are these mounted? If we do block, it doesn't show, or do it show? So this is the device. This is the partition 1, partition 2. The 16 gigabytes one is used for this. And the whole 100 gigabytes partition is used as swap. Now, is it possible that these two can be sometimes swapped? I have no clue. We do device names here, but that's not really helpful, I think, because we are using this super smart kernel feature to name it differently. So I don't really know if these two can appear in an incorrect order. And I think, by the way, we are also doing some check somewhere. Generic mount, this one. So, okay, generic mount is not used in our case. Generic mount is used only on hypervisors and only on the IBM Cloud. Which means this check is not being done at all. And maybe that could be the solution. So I don't think so. I don't think the problem is here. I think the problem is actually calling it on the incorrect device here. Where is the output? Yes, I would bet you those two are swapped. I think we need to we somehow need to do this conditionally. So how would we do that? How would we go about that? So get size vol block there. Okay, so what is this actually? If we do block dev get size 64 off, I have no idea. What if we try just this? Because this is what we ultimately want to pass as the argument. Yeah, okay, so no such file directory. If we do /dev this, okay. So we can do something like this. And we can do same way as they had, size equals this, right? So if this size is larger than something, and I'm really bad at writing bash, so we will do something very, very stupid right now. We will do it on the on the builder. I'm going to create a new script. So I don't know, hello sh, doesn't really matter. Vi, hello. And what we are trying to do is this. And then condition, right? So the condition also bin bash. So we have the size and we want a condition. So it will be something like if test now test the size le now number now some number, let's do 1 2 3 to be syntactically correct, then phi, and we will do also elif, not elif, else. So print, no print, not print, echo bar, echo foo, right? This is kind of correct. We need to do this number. So block def get size 64 man block def size 64 in bytes. Okay, so 100 gigabytes in bytes is this number. So this is the number we are going to compare it to, right? Does this make sense? 1 2 3. Okay, we will close this, chmod plus x this, and run this. It prints bar. Because we will probably want to do greater than. Okay, so if we do lsblk, we tested this one, which is larger, and therefore we are printing foo. What if the disks swapped and actually they were attached in the different order, and therefore this one would be, yes, they were in the different order, right? So if we run the hello now, it prints bar. Okay, so this is syntactically correct. I just wanted to try because I'm too stupid to write this code like first try without testing. So yeah, this is our condition. And we will put it here, right? Right. Now, if this is larger, then we are of course going to repartition then we are of course going to repartition this one. Otherwise, we are going to repartition this one, right? Does this make sense? Does this make any sense? I think it does, actually. I think it does, actually. We will write some comment to this. There is 4 GB on the default volume in our instance type, sure. Now, let's do something like this. However, sometimes the devices, can attach in an unexpected order, so we have to pick the correct device. This is of course, all of this is of course just speculation at this moment, right? Because we didn't verify absolutely anything. But that doesn't matter, because I'm going to propose this pull request, or this change as a pull request, and then I will have a meeting with Pavel today, who said he exactly knows where the race condition is, so he can confirm if this will help or not. Maybe we found the incorrect place. And then of course we will test this on staging, so we will confirm it helps or disprove that it helps. So for now, the speculation is just fine. We should check out a new branch. So AWS device, good enough. Good enough. And do we have some conventions in the commit messages? It doesn't seem like we do, so pick the correct device, AWS device, for repartitioning. Repartitioning. Yep, okay, so this will fix. We need to link the whole issue because it is a different repository. And I think this is good enough, right? We are going to push this onto my, I don't have a fork of this, seems like. Therefore we will going to fork it. I think I can close all of this because it's just confusing. And Copper image builder here is available, which means I don't have to fork it, I guess. Anyway, we are forking it. We are going to edit the git config because I don't like the git add something commands. And this is our repo. So, oopsie daisy, here we are going to add a new repo like this, new remote, I mean. And we will git push here. New pull request. Looks reasonable, right? Just to verify there aren't any tabs or something like that from where when we copied. Looks good. Okay, it looks good. I'm going to create a pull request. This is just my speculation where the race condition could be. I didn't test the code yet. That's fair, right? All right. And we are an hour in and we perfectly finished the first investigation on time, so I'm proud of us. Now I'm going to sign off and I'm going to have the talk with Pavel, and we are probably going to work on getting this fix into production after that meeting. So yeah, I will definitely do the next part on camera, so you can see the finished whatever word I'm looking for. Anyway, also it is entirely possible this is incorrect fix, and we will need to get in there again and revert this and fix something else. So yeah, it's also possible. So yeah, we will see after the meeting, and I will let you know in the next video. All right, thank you very much for watching, and see you next time. Bye bye.